I'm doing well. How are you?
I'm good. Excited that we're halfway through physics.
Right?
All right. Should we get started?
We shall.
I know I'm always like, I feel bad with these meetings, but I'm like, let's get it over with. Let's get it over with.
Oh, it's
Not
fine.
that it's physics and I don't want to.
I don't blame you. So,
All right. So, what did you put for number one?
so for number one, uh, by applying the same amount of force while increasing the length of the object that is perpendicular in direction, the applied torque is increased to loosen the bolt. I also put this is not a hazard. This is not a hazard because the applied force isn't increasing, only the distance from the pivot point.
Yeah, you got a little more into it than me. I just said adding pipe increases length, which when you apply force at a greater length causes more torque. So we can use yours for that one.
Okay.
For number two, for A, to calculate torque, I did the T equals RF. So it's the 0.14 multiplied by 165, which was 23.1 newtons multiplied by um, meters. And then for C, I just converted it to feet to pounds. So I multiplied it by 328 feet over 1 meter, multiplied by 2.205 pounds per 1 kg, and 1 kg divided by 9.8 newtons. So I got 17.
I got those two.
Okay. How did you do number three?
So number three, um, so we know that the little squiggly T, I keep forgetting what it's called, but is set at 0, so they're equal to each other. The two balances on the seesaw.
Yeah.
So I used the equation mgr equal m1g r1 equals m2g r2.
Yeah, that's what I use.
And so when distributing it out, I ended with 20 times 9.8 times x equals 30 times 9.8 times 3 minus x because of the.
Yeah. I see that now.
And so I ended up with 20x equals, and then you distribute, so you get 90 minus 30x because the 9.8s cancel out. So you end up with 50x equals 90, putting like terms together. So x equals 1.8 meters.
Yeah, that's exactly what I got. All right. For first you had to calculate the work for both of them. So I did the W equals mg for both the bridge and the car. For the bridge, I got 24,500, and for the car, I got 8,820. And
Okay.
then I use the equation F equals the W for the bridge plus the W for the car minus T sine theta. And I combine that with the equation F equals T cosine theta. So then I multiplied the work from the bridge multiplied by the 1.5, which was the distance here.
Okay.
And then I added that to the W for the car, so 8,820 multiplied by 1.5. And then I set it equal to T sine 40 multiplied by 7.5, which was the other length on the bottom of it. And then when you get the whole thing, you get T equals 10,367.34. So 10,367, but you have to divide it by 2 because there's 2 cables. And then for the one
Okay.
cable, it would be 5,183 newtons.
1,583 newtons. That's what you got?
No, 5,183.
5,000.
What did you get?
Huh. So for both of them, I got 14,498.56 newtons. And then per cable, since you divide by 2, 7,249.28 I'm trying to see what. So I did small mg times 1.5 plus large mg times
Well, what did you
3.75.
get for NG for both of them? So your W for both of your work.
Hold on. I plugged it into the whole equation of just the small mg
Oh, okay.
times the, I forget what goes there. I'm trying to, oh, I'm looking at it. So the distance of 1.5, where that work is, plus the large mg times the 3.75, since that's halfway,
Yeah.
minus t times 7.5, the whole distance, times sine 40 equals 0. So when I plugged it all in, that's what I got with that equation. And I know you use that equation,
Yeah.
so because I was following along.
Let me throw my calculator one more time. But I could have sworn I did that right.
I'm gonna try it too.
I'm
Way
gonna
to the
flip it up
bridge.
like you did, where you added NG to it.
So these are the numbers I have after rearranging for solving with t.
Mm-hmm.
2,500 times 9.8 times 1.5 plus 900 times 9.8 times 3.75.
I'm still getting the same numbers. Right.
Well, all divided by 7.5 sine 40.
Yeah.
Oh, I might have done something
Wait, tell
wrong
me
then.
one more time. Tell me one more time the numbers you were using.
Okay, so the top part you should have, which is,
Yeah, and it's all over sine 40 multiplied by 7.5. So what's the top reading?
so let me plug it in one more time. So when the whole top is put together,
Mm-hmm.
I get 3,675.
Let me see what I get.
That's the whole top put together.
I get, what did you get? 30,000 something?
3,675 doing the whole top part together.
Okay.
That part is,
I'm getting way more than that. Because I'm multiplying the 2,500 kilogram bridge multiplied by gravity, which is 9.8. And then to get W, and then for the little W, I'm doing the 900 kilogram car multiplied by 9.8. And then I'm multiplying both of those by 1.5 and adding them to each other. And then it's equal T sine 40 multiplied by 7.5. What mass and what are you using for
wait, did you say you times both of them by what distance?
1.5?
I'm using two separate distances.
What other distance are you using?
So it says halfway between the hinges and the cable attachment. So I'm using the 7.5 divided by 2 for one of them and the 1.5 for the other, for the hinge area.
I mean, that makes sense. Which one are you using that for?
So the car has the 3.75 since it's with its center of mass halfway between the hinges and the cable attachment.
Okay.
And then the 1.5 is with the bridge.
Okay, I can accept that. That makes sense.
Okay.
All right, we'll just use yours for that problem.
Okay.
And then for B, I did the F equals T cosine theta for the first one, which gave me 7,000. Well, I don't even know if these will be the same. What did you get for these ones?
No, they wouldn't be the same.
My total force that I got was 7,944.
The overall force I got was 26,476.5. And then an angle of 65.19.
What did you get for the total force?
26,476.5 newtons.
I got 26,656 newtons for one of the forces, and not for both of them. Did you do the F equals the square root of like F1 squared plus F2 squared?
Yes,
You got that? Okay.
I did.
I mean, I guess that makes sense. That's way more. Because this is saying it's only like a little bit more than the first one. Find the force, find the direction and magnitude of the force. Okay. How did you get your direction then? It was just the tan -1 from, I used tan -1 of the big W for the bridge and the little w for the car, so I got 70.2 degrees.
And that's what I did with the numbers I had with the forces. The Fy over the Fx arctangent.
I didn't use the force for that. I used mg for both of
You
those.
used
So m1
that.
over m2g.
Hold on a second. I used I went back to the equation, big mg plus mg minus t sine 40 for Fy.
Okay. All right.
That's what I
On
used.
this one, because what you're saying, well, the direction part of yours where you say it's halfway between, because I didn't even think about that, so that makes sense for me.
Okay.
So I'm just gonna say you did it right.
Okay. Thanks for your confidence.
Well, I'm very not confident in my abilities to do physics, so you know, by default, you're the confident one.
Yeah. Okay. This one was kind of crazy. There were a lot of.
There was like a lot of steps you had to do before you actually got to part A and part B, which was super fun. So basically, I took the equation that, well, the principle that the net force should be equal to 0. And so I had the N1 plus N2 minus W should equal 0. And then I arranged that to give me 2N equals mg, which when I calculated that gave me 49 newtons. And then for the length I had for A is 0.55 meters, for B it's 0.65 meters, for C it's 0.5, and for D it's 1.3. And then to solve for T, I did T equals 1 over C, and then multiply by NA minus W minus A over 2. And then I got T equals 21.6 newtons. Okay. And then for A, I did the coefficient of friction multiplied by N equals F cosine theta. So I did mu multiplied by 49 equals 21.56 cosine 0, which just gave me M equals 0.44.
N gives you that?
That's my coefficient of kinetic friction is 0.44.
Okay. Yeah, that works.
Okay. And then for B, I did F cosine theta is just equal to what we already saw. It's the 21.56. because you do F cosine theta equals 21.56, but you're using cosine 0. So F just equals 21.56.
Okay, that makes sense.
Okay, and then for number 6, for if is the nail polar in equilibrium, I said it's in equilibrium because there's a net force of 0. Then for what if you pull the nail with some acceleration, is it still in equilibrium? I said no, because acceleration will add extra force, so the net force is no longer equal to 0. And then for 3, I said force applied to the nail puller is larger because the extra force added, you need to add extra force to accelerate past the equilibrium. So the fact that it's accelerating at all means it has more force. Is that what you said?
That's basically what I have. So,
Perfect. All right, what did you get for 7?
so for 7, okay, holy time. When I printed it off, it was on 2 separate.
Mine is like totally weird. Like this is the picture for 6, and then my 7 is like down here, and my photo for 7 is up here. It's a mess.
They need to work on that.
Yeah.
Okay, so for 7, so I set it up with 2t minus mg equals 0.
Mm-hmm.
And so I was solving for t, so I used to move the mg over and then divided it by 2.
Yeah, that's what I did too.
And so then I got the 115 times 9.8 divided by 2 to give me a tension of 563.5.
Yeah, that's what I have. So I just rounded it to 564, but that's what I have.
Okay. I'm starting to get confused with the significant figures. I know how to do it.
Yeah.
But in a lot of the problems, even I went ahead and did the quiz for the week, and one of them, you should only have 2 significant figures, but the answer they give has 4, 3 or 4.
Yeah, you should email him. Maybe you'll get extra credit.
But so I'm being thrown off a lot.
Yeah, I don't blame you. All right, then how did you do B?
So B, I did the force minus 3 tension equals 0. So then,
I have
since
it.
we
The force equals 3t, and then you multiply it by A, right?
I just have F minus 3t equals 0.
And then what did you solve it for?
I'm solving for the force. So
Yeah.
what is the force that's applied to the ceiling? So how did you set up your equation?
The same way, except then I subtracted the 3t to the other side, so force is just equal to 3t. So I did 3 multiplied by 564, which gave me 1,690.
That's what I have too.
Okay. All right, for 8, which is, can you pick up an object that weighs 1,000 newtons if the maximum force you can exert is 1,000 newtons? I said no, because to pick it up, you need to use more force than the actual weight. So since you can't use more than 1,000, you can't pick up something that weighs 1,000 newtons.
Perfecto.
That's what I like to hear. All right, and what did you do for number 9?
Okay, number 9. Yay, it's finally just on one piece of paper.
I know, it's like the only one.
You know. So I did the. Okay. So I did the F times 2 because of the R perpendicular equals W1 times the R, what is it, prime?
Yeah.
And then it's a WL for the leg, my bad. And then a WC for the child times the 38.
Yeah.
R prime 2. And so first I figured out the forces working on the child as well as the leg. and then I moved everything over. So I divided everything by 2 to find the force. So 39.2 times 20 plus 98 times 38, all divided by 2.
And what did
And
you get the final?
I got 2,254 newtons. Or if you want to keep it with sig figs, 2.25 times 10 to the third.
So I used a different equation,
Okay,
and I
go for it.
answer that's somewhat vaguely similar. So I did FR1 equals M leg R plus M child R. And so is M leg R prime plus M leg R perpendicular plus M child R prime, or whatever the quotation marks are. And so I did F multiplied by 0.02, because I converted them all into meters, equals 4 multiplied by 0.2 plus 10 multiplied by 0.38, and I got 230 newtons.
Oh, I see what you. Okay, let's go with yours on that one because I didn't convert it. I did centimeters.
That's what I was saying. I was like, they're very similar. I think you just didn't change it because they're like basically like if you rounded yours, it would be the like 2,300.
Yeah.
Okay, so then you're going to send in picture number 4 because I clearly did not understand it. So I can. What is there? There's 9 photos. How many pages are there? 1, 2, 3, 4, 5, 6.
1, 2, 3, 4. Yeah, 6.
So why don't you send me the first 2 pages and I can do the last 4 pages since those are only 4 problems, right?
Okay.
3,
Right.
4, 5, 6, 7, 8, 9. Yeah, I'll do the last 4. So you do 1 through 4, and I'll do 5 through 9.
Sounds good. I'll get these to you then.
All right. Sounds good. Let me stop this broadcast.